I know a lot of you are searching for a 3D printer that can print large objects very quickly without having to spend hours and hours to assemble and tune it. This could be the printer you have been looking for. This is the TEVO Delta. It has a huge build volume of 340 by 500 millimeters, pre-installed BL Touch for automatic bed leveling, and it can print at extremely high speeds. You can find it on AliExpress for $940 with free shipping. The package was like super light, no problem to lift at all. No, but really, the packaging was just fine, all parts arrived without as much as a scratch. To give you perspective of the enormous size, here is one of the aluminum profiles. The heated bed was fairly large as well. The hot end is very compact with 2 cooling fans already in place and the BL Touch pre-installed. It also features a MKS S-base controller with smoothie wear. All the wiring has already been made as well. The cartridges arrives already assembled and uses wheels instead of linear bearings, which I have become a big fan of. This is a Titan extruder and works with all the filaments, PLA, flexible, wood, to name a few. The provided display is actually a touchscreen and made scrolling through the interface very enjoyable. The power supply is all integrated, so you don't have to wire mains voltages, and that is great. It's also fused for some level of safety. You have 2 USB outputs that can be used to charge, for example cameras, if you plan to record your printing process. The miscellaneous parts was organized in bags that was labeled and referred to in the manual for each step and made it very clear for how to assemble the printer. You will also get this very handy print removal tool. Alright, let's get started with the assembly. Now all we have to do is insert the provided microSD card and turn it on. Now the first thing you want to do is the calibration. It will start to heat up the bed and automatically level it by the BL Touch sensor. This is very convenient and will save you a lot of time. I then grabbed a roll of PLA filament and pushed it into the Titan extruder till I could see it coming out the nozzle. Now we are ready to print, and what we have to do is transfer a G-code file that the 3D printer will be able to read and print our object. And there's a couple of different ways you can do this. One way, also the easiest way, is to head over to Thingiverse and search for whatever you want to print. You will probably get a ton of results, but once you have decided which one you want to print, simply download the file and bring it into your slicer software. Maybe change a couple of settings. I increased the temperature to 210 centigrades and the layer height to 0.3. Remember that this was all pre-configured settings. I didn't tune or make a single modification, and it already looks better than some of the printers I've been tuning for months. The average noise level was 58 decibels, the exact same as the Anite 8. It is not a quiet machine, but it's not loud either. The blue vase turned out amazing for being the first print ever. I also made a red one and it turned out very nice as well. I was interested to see how this Delta printer would handle precision, so I prepared the 300% boat to print, and I think the result speaks for itself. Let's see if it can handle the flexible filaments. By using Fusion 360 I designed a handle, and this is the second way to generate your STL file. In a CAD software you will be able to sketch up anything however you want it, and I think that's a very creative way to make things. Not only was it able to print the flexible filament, but it was also able to do it at 30 millimeters per second, which is considered to be fairly high speed for a filament this flexible. It turned out great and with very good layer adhesion. Delta printers like this one are made for speed. The reduced weight of the print head has the benefit of reduced inertia, and this means that the hot end should be able to respond very quickly while retaining accuracy. The reason for the clock is so you can see that I don't speed up the footage. The default speed from the slicer was 100 millimeters per second, and that's what this looks like. I then manually increased the speed to 150. Not too exciting, so I bumped it up to 300, and to my surprise it still managed to print with no problem. At 350 was no longer able to sustain a good printing quality. At this point I just wanted to print something super large, so I scaled up the rocket by 700%. Alright, let's recap my review. The packaging, great. It's very heavy, so you are guaranteed to make some muscles. The construction is robust. I mean, these aluminum profiles are massive, and the top and bottom plates are quite thick as well, so there's no wobble. Everything seems to be very sturdy, and this is still obviously a DIY kit. But it does come mostly pre-assembled, so the time to assemble it is only a few hours. Complaints about the components either. The heated bed heats up surprisingly quickly, and I had no problem reaching the high temperature that ABS requires, and the fact that it also prints with all the filaments is a huge advantage. I'm very happy of how well it works. I didn't have to make a single modification, and I didn't have to spend hours and hours tuning the printer, which usually is the case. It simply works, and the fact that you can print at those high speeds is great. To me, it's one of the most important aspects, because when I have an idea for a project, I want to print something, and usually I go to my CAD software, and that doesn't take very long time. What does take a long time is the printing process. But now the printer is so fast, you can go from an idea to a physical object very, very quickly. If you have any questions, let me know in the comments below. Follow the link in the description and that will take you to the printer for you to pick one up. Let me know what you thought about this review. Have a nice day. Bye.